Forgive me for the fumbling. My name is Richard Revels. I work for Bandwidth. I've been with Bandwidth for between 6 and 7 years. And before that, I worked for a company that provides inmate calling platforms to prisons. I mentioned that, so you'll have a little context for my next comment, which is that for Bandwidth, I worked as the inmate guy, a network engineer, director of network engineering, the old guy that can't get shit right, and now senior platform architect. For any of you fellow platform architects that are out there, I'd like to suggest that anytime you start feeling pretty good about yourself for accomplishing something in a particularly clever way, if you will think about that progression, it should help bring you back to earth. It does myself. So today I'm going to be talking about interfacing with OpenSIPS peripherals, and by that I mean things that are not built into OpenSIPS, but that can help the platform to hopefully perform in a better manner. And I'm hoping that this is going to kind of follow on to things that we've heard from Bogdan and Vlad about the scalability of OpenSIPS. And I'll try to get through this fairly quickly because I do have quite a few slides beyond moving. Some tools will allow us to refine the capabilities that OpenSIPS has, and then others will allow us to take things out of the config that maybe could be handled a little more efficiently outside. I'm going to take a look at monitoring statistics, some benchmarking, which is built into an OpenSIPS module, and get a little bit into event notification. I know that there are platforms that are taking advantage of the event notification already to do things such as CDR generation and Apple out-of-band notifications that I think we're going to see more and more of as time goes by. And so as the support for event notifications, for registration and things like that are built out further, that will be particularly interesting. I'm going to start with monitoring, particularly with Snmp. Snmp is one of the more prevalent Snmp mechanisms out there, and to go along with that, there's the Xenos monitoring system which supports Snmp, and there's many monitoring platforms out there which do understand Snmp. Xenos is not necessarily the best one. I may have skipped a line on a previous slide. There's very rarely a single best way to do anything in computing, whether it's call processing or word processing. But this is one of them, and we've found some success with it. And then I'll touch a little bit on rsyslog. The Snmp setup, you have the normal config file that will come with any distribution. I haven't shown that on here. Things that we're going to be particularly interested in are the pass commands. Is everybody familiar with Snmp? Yeah, I see a fairly decent smattering. So in Snmp, you have OIDs that you use to query for values on your server. And we're telling it that the 255.4 tree, we would like this script to be called, and the .5 tree, we would like this script to be called. This is an OID that has been defined as a user available OID to be used for the pass command, amongst other things, but that's one. And then we'll set a destination for our traps of, in this case, Xenos, that's your host monitoring system, and then the community string, I'm using whatevs. And after you have that set up, OpenSIPS has support for Snmp queries natively. You can find a list of these on the documentation page for the Snmp module. But if we look at this one, if we were to use the Snmp walk command to query that, as a matter of fact, if you use this command line to query that particular value, you would come back with OpenSIPS current number of dialogues, how many calls you have in progress. So you can see my proxy was a little light on calls that day. But then if you tell it to output numeric rather than a string, it will translate that into an OID. Why do we care about that? Well, the automated monitoring systems will use those OIDs to go get those values for you. So this is a screenshot from Xenos. What you're seeing here has nothing to do with OpenSIPS particularly, but it will monitor the rest of the system as well as your OpenSIPS installation. You'll have process monitoring where it will send out alerts, email, SMS, whatever. If those processes go down, you can also tell it you want to know if they restart. It'll watch your disk space for you and your utilization on your network interfaces. And like I said, Xenos is a monitoring system that we use. It's not the only one out there. Many of them will do this for you. You point the system at the IP of your proxy, and it grabs this stuff from the Snmp interface automatically. Now I'm going to step back for a minute to the pass command that I had referred to earlier. With the OpenSIPS native support, you can find the number of invites, the number of responses, 400s, 200s, all that stuff. But there may be things that you want to drill down a little more to. Like, you don't just want to know the number of inbound or invites. You want to know how many of them were in, how many of them were going out, how many of them were on net. And all of these things you can declare as statistics in your config. And using the FIFO command, you can get those values out, and then they can be passed to that pass command and returned to Xenos, which will track it for you so that you can watch trends over time and see when auto dialers start up and things like that. And it is possible to simply have a script in your pass command that runs the FIFO, and then you grep out what you want. I found that to be somewhat cumbersome, and it's normally better to have a cron job that runs the FIFO command, getting the values every once in a while, a minute, 2 minutes, 5 minutes, and then just use your pass command to grab the individual value out of that file rather than going through the FIFO itself. But you can get anything you want out of the script using this method. And this one also, maybe not Alex's restaurant. The menu.
You get a number of active calls?
The number of active calls is available. As a matter of fact, you wouldn't have to do anything particular for that. If you're using the dialog module, the dialog active calls will show you that. But if you're not using the dialog module, you can set a statistic and increment it each time that you set up a call, decrement it when you get rid of one, and it will come out through the final information. I have some files that I'll make available. This script and some other things. But the output of your pass script should look like this. The OID that it's responding to should be first, what type of value it is, and then the actual value. This is a sample of the cron command I was referring to, where you just slap the stuff into a flat file and then grab out the value that you want when the pass command comes through requesting. And the end result is that your memory from OpenSIPS is tracked. In this case, the calls per second. And as I said, this isn't a real heavy proxy. And the active dialogues, which would be your concurrent calls at that moment. And anything else that you want. That's what I could fit on the screen. So over time, it is important to know what your baseline values are, and then track those. And you can set thresholds on any of these values so that you get alerts and things. For rsyslog, this is also tied into monitoring as well as external processing of maybe CDRs or benchmarking values. But again, this is a part of a distribution generated file. With these two lines, we've told the rsyslog facility, everybody's familiar with rsyslog? Or most, some people. We've told the rsyslog facility that we want to look at system messages that contain the words benchmark, timer, and we want to send them to a remote syslog server, and then we want to drop them and not do anything, so we don't want to write them to disk on our local machine. Then we've told it that anything going to the mechanism local 0, the facility local 0, which is defined in the OpenSIPS config for syslog, that we want to have a traditional format, which is defined as, I want the date, time, what process created it. And we also want to go to this file, varlog OpenSIPS message, and we also want to send it to our local or our remote collector. The OM proc says I want an output pipe that doesn't go to file. In this case, we're going to call a application anytime we get a call to this. And the application that's going to be called in this case is user local scripts web hits. Anything going to local 1 will first go to this file, but we're also going to call that OM prog that we just defined up there. And the output of the rsyslog entry will be connected to the input of the script that is being called. We can also put in things like, if I get messages that say out of package memory, no private memory left, severity is high, anything like that, I want it to go to the Zen collector, which is, in this case, Xenos will listen for syslog messages on a port that you defined. You notice that on the previous page, port 514 was the syslog port that our remote collector was on. Now we have 2514 on that same server where Xenos is listening. When it gets one of these messages, it will create an alert under the device that sent that message. So it's good to know when you're out of package memory on a OpenSIPS config, bad things start happening, and you're going to want to go probably roll the proxy. For the central server setup, we tell it to listen on 514, what the IP is we want it to connect to, and we can do further processing on messages that show up. We create 2 templates here that define what files messages will be sent to. In this case, we're breaking it out by from host. That's going to end up being the IP address where the message truly originated. And we have a benchmark file and an OpenSIPS message file. Down here we say if the message contains benchmark, we want to use that template that we just defined. And end, we don't want to do any further processing with it. But then if it's local 0 anything else, we want to go ahead and use the second template that we defined, which will send it to that log file. Now these things are being done off of your proxy so that you're not hammering the disk when you start generating thousands of messages per second because something's not going quite the way you anticipated. So that will definitely help your I/O on a couple hundred or 1,000 calls a second. Also, I'm using rsyslog. We found that syslog has a tendency to block when you start sending massive amounts of messages to it. rsyslog handles that much, much better, in my experience. The outcome of having the config on the remote server that we were just looking at, this is a tree of the Barlog OpenSIPS remote. You have the 2 benchmark files that came from 2 different servers, and then an OpenSIPS file that came from a third. Well, one of the same 2 here. And I put in some samples of the benchmark output. This is directly from OpenSIPS. You can tell it in the config, I want a log output every 100 messages, every 1,000 messages, every 10,000 messages, whatever. In this case, it's every 1 message. And it spits out the average, minimum, and maximum times, along with the number of messages that are in that sample, in that same information since the proxy was started. So I'll kind of leave it up to you what you do with this information once you have it available in this log, but we will touch on it just a little bit with the rsyslog entry that we were looking at earlier for spawning applications. One thing to notice here is that we used 43 milliseconds. This was on a T-relay. That's all it is 2 benchmarks around a single T-relay command. So if I'm taking 43 milliseconds per invite to do just T-relay, I'm going to have a hard time getting to 1,000 calls a second. So most likely I've got SIP trace turned on, and I'm writing some traces to the database with each of these T-relays. Down here, I'm storing a value to the database, and 24 milliseconds on that one. These are kind of contrived. Like I said, it's an average of 1 message. So, but again, having a baseline and then being able to compare over time will be an invaluable resource. Moving on a little bit for external notifications of things that are happening within your proxy. The Pbx Control Module is something that last year at boot camp I said I was going to release, and I just needed to get the documentation. I still haven't written the documentation. It will be released today. It will be available in the disk share that I'm going to make available in some manner. And I have a Google folder that I can share, but I would have to know email addresses to do that with. So I'll get with Bogdan before we get done.
Sure.
And oh, okay, I didn't even know there was one. I'll share it on the Google Plus OpenSIPS page. And we'll get a note on the mailing list to let everybody know that exists. But the Pbx Control Module, it has a few, actually I've got a hastily constructed screen that shows what functions are available, but it will allow you to talk to a free switch or asterisk over the manager interface from within the script. So, for example, if you wanted to set a UUID variable in a free switch script from OpenSIPS, it would let you do that. Or if you knew what the UUID from a call is, and you wanted to end it on free switch, then you can do that. I use those 2 examples because we've done that in a platform where we parked a call on FreeSwitch. In the 180 coming back, we stored the UUID from FreeSwitch and then put that into memcache on OpenSIPS. When the user registered, if they registered, then we would pick the FreeSwitch UUID out of memcache and tell FreeSwitch to drop that call so that we could get it back onto the OpenSIPS registrar. And it works exceptionally well. The software itself may not work exceptionally well because it did the job I needed it to do, and then I never went back to it. But hopefully someone will find some use for it. The second thing is the web hits with rsyslog. Now this is done with the rsyslog command that we were looking at, and I believe I come back to that. Yeah. Once again, this is the rsyslog config that we were looking at a little bit earlier. We're telling it that we want to spawn this program each time that we get an entry. And in this case, I'm using the accounting module in the transaction mode so that it's not creating a CDR per call, but rather you're getting an entry into your accounting for each transaction. Invite, buy, 200, whatever the case may be. And instead of, I am saving it to a file here, but that's optional. In the production platform, we were actually bypassing the file altogether and doing CDRs offline. But we were calling this web hits program. rsyslog will look the first time and say, is web hits running? And web hits is nothing magical, it's just the name I came up with. You could call it external notification. Just some program that's sitting there able to handle text input. And if the file is not running, it will spawn it and then leave it running so that you don't have the overhead of restarting this application each time an accounting record is created. And in this case, we were looking for invites to come in, and we would grab out the from user and the to user and send that to a web proxy via HTTP, and that would be then forwarded on to one of those magical little Apple notification servers that let the user know you've got an inbound call waiting for you. Run the application. If they wanted to do that, then the whole registration process and dropping a call off a FreeSwitch and everything like that would come into play. But this is the application that would just sit there and watch for calls coming in for unregistered users and then send out a notification. And this is done offline outside of the proxy itself. By not running it to disk and having this running in a threaded module there, we were able to handle, well, we were doing about 32 calls a second, but you could do as many as you would like without impacting the performance of your dial line at all. You have the call sitting over here, the inbound call sitting over here, parked away from the proxy, and the notification process happening offline in our system. I'm going to run back to this for just a second. Like I said, this is, I just went into the software and grabbed the things, but FreeSwitch refer. So if you want to tell FreeSwitch to transfer a call somewhere, the module will let you do that. Transfer is actually moving it off of the box to another endpoint. End UUID I mentioned already, and set UUID variable, and then asterisk originate. I haven't ever used that in production. I did try it out a few times, and it will originate a call and send the two legs with good dial plans.
So where did you get the UUID in ranging, 180 ranging?
If you're going to have to do that in your FreeSwitch config, when you send the call into FreeSwitch, it is up to you what you're going to do with it. In my case, I told it I wanted to send back a ringing indication, and I created an X header. And one of the variables from within the pre-switch dial plan is the UUID of that leg of the call. So in the X header, I put the UUID of that leg of the call, and then OpenSIPS just grabbed that X header when the 180 came through and stored the value that was in that X header into memory.
Where would you, is it like a separate table you store it? Or?
Well, with memcache, it's just key value pairs. And in this case, I would use the call number, the call ID as the key, and then the value would be the UUID. And actually, I am.
But then how would you know what call ID is for what call?
Oh, let me get one more thing and then I'll open it up for questions. So the program that we were just looking at, this is an example of the notification services that it would send out. And all of this information, like the to user, the from user, the disposition, all of that stuff was taken from the messaging in the OpenSIPS config out of the accounting record. So I had to do basically nothing special other than parse out the line, grab the fields that I want, and shove them into the HTTP request. The source code is set up to send the yahoo.com. If you decide to try it out, change that. They probably won't notice you're there, but it's not going to work too well. Oh, geez, I have two more. I had two more things. So last thing, and then I'll get to the questions. The event interface, and this for people who are familiar with RabbitMQ, I don't really need to speak to it because you're familiar with it, but it is the same type of mechanism as this. For those of you not familiar with it, messages go onto a base and you have listeners, onto a message bus and you have listeners that are listening for those messages. In this case, I'm just looking at the event, the UDP event socket itself. In the config, you set values, attributes and values, and as you know, if you set more than one value on a AVP, it'll create an array. And so you set the values that you're interested in getting, and they could be 20 long, if that's what you want, and then raise the event. So as the call comes in, you grab the values you want, you call raise event, and then I'm in-grepping on 1984, which is the port that I've told it to send on, and out pops a UDP packet with event zip invite as the event that was raised from within the config, and then the values along the key value pairs that were defined within the config. And as I mentioned, you could have an entire CDR in there if you wanted to. And it just happens magically. It also does not lock. I've sat there and ran calls through a config where I had no listener on the port at all, and it was completely happy. But you can now do those types of external notifications that I've been talking about without having to worry about anything other than what's built into OpenSIPS. So the modules and things that I've been talking about for the last 5 minutes are about to become obsolete. But that's all I've got to present. Are there questions? What were you asking me about?
So you said you save the UUID as an X header in OpenSIPS?
In an X header, in the message, and then when it comes into OpenSIPS, I grab the value of the X header, and in memcache, I would store it as the to user underscore call ID. And the value that would go with that would be the UUID that I pulled from FreeSwitch. And then when the user registered, I would look up as to user.
Registered how?
Well, the SIP client. So this is in the event where a user is not registered to the proxy, but a call comes inbound to them. I want to send them an external notification. I could do an SMS, an email, whatever the case may be, for as long as I want to hold the call. And then if they register, the problem is, gee, I've got them parked over here, but they're registering to my OpenSIPS proxy. And so when a person registered, I would look to see if I have a call waiting in Memcache for that user. And if so, then I would go tell FreeSwitch to drop the call and we have a chat. When the call comes back to the OpenSIPS, it would be on a 404 message or a 400 series message, and that would cause it to hit the failure route on OpenSIPS. OpenSIPS would then look in the registration, the Memcache, for a registration record, and this time it would be present where it wasn't present the first time. So it would notice and
What's the use of this?
in this particular instance, hopefully you'll find a lot of uses that haven't been thought about yet. But in this particular case, it was for people using iPods with SIP clients that they didn't want to have the SIP client running all the time because that would kill their battery. And the Apple notification service does run all the time and works exceptionally well. And so when the call came in, they'd get the notification through the Apple notification service. And if they chose to run the SIP application, when it registered, the call would make it into them. So we were just holding up the call while we decided if the user was going to register.
That's a good use case for it.
It was a good use case. We had a lot of fun with that stuff.
It didn't work out the way you wanted?
No, it didn't work out. We built that for a customer, and they took it on their own network after the proof of concept was done. Now, I say proof of concept. In order to build to a proof of concept, we did 4 million numbers. We would have 60,000 users registered at any given moment, and up to 3,000 concurrent calls. So at that point, it became a viable platform, and the customer took it on to their own networks. But with OpenSIRP, the sky's the limit. And hopefully, this will give some thoughts about other areas like this.
Do you think RabbitMQ is going to take over some of this? Since things are just better now?
I think the event socket is going to take over external notifications that you will notify as
So anything that communicates with the event socket?
well.
Not necessarily RabbitMQ.
Yeah, now RabbitMQ is a building thing. It's above event socket, and this is a UDP socket that you build a application that listens and reacts to. Where RabbitMQ, somebody's already built it.
Yeah.
You just say, oh, I want the listener over here, and OpenSIRP will find it.
I'm using RabbitMQ and it works like a charm. Used for prepaid. It's really nice.
I see that you are using the Snmp quite a lot, and actually the memes which are published by OpenSIPS are holding these are a draft or something saying what kind of memes should be published by proxy. And I don't know, all the time I have the feeling that they are not, let's say, sufficient, or sometimes they are not reflecting, or you don't get some really relevant information from, let's say, from OpenSIPS via Snmp. So I don't know, does it really make sense, let's say, from usage perspective, to actually forget about what the draft says and extend the list of MIPS. You know, even if they are customers. After all, what's matter is to get you know.
Yeah, they do indeed fall short when you're trying to use them. I've never successfully walked the OpenSIPS tree with the MIPS. I always have to go in and slap the OID itself in, and then it will walk the tree with no problem. So from my perspective, I could care less about the draft. When I run Snmp walk, I really like to have it go. And if we can do some refinement in there that will make that more seamless, then.
But if you want to do monitoring, for example, you don't have access to information like how much memory it's used, what
Right.
is the load, I mean things which are really relevant.
Right.
And they are completely missing from the kind list.
Well, one interesting thing also is to talk a bit about this statistics that usually nobody knows, like loads. It's something really interesting to check on the system, like NetGDP, 90CP. Things that we take forever to learn that there's a load that can say how many children are using it at this specific time, and you can know if it's blocking or not the whole system. It would be interesting.
Oh, that's another thing is that the UDP weighting buffer is something that's available in statistics, and you can easily get them out into a monitoring system.
But I love this statistic called load. It's,
Coming back to this, in the Snmp statistics that are available, package memory now is being tracked as of 1.8, I think. I think it's 1.8, maybe 1.6. But so you can, in addition to the memory, the shared memory that's being used by the proxy, you can see the individual threads off of the package memory. The individual package memory statistics by thread. But one problem that you have is that if your proxies are not consistent across all of your base, is that you may have like 15 threads over here and 10 threads over here. The package memory is going to have to be defined individually on those charts, and haven't found a good way around that. But yeah, we have found that the Snmp mechanism will do a lot of information for you right out of the box. I don't know if I went over time or not. If I did, I apologize.